Okay. So we'll start with SQL, an overview of the class. Today, we're going to be talking about what a database is. We're going to talk about what's in a database, and then we'll get into structured query language. We'll look at demonstrations of how that is written and how that is executed. We'll talk about the language elements of SQL, and then we'll experiment with some aggregate functions. All right, first, what is a database? A database is an organized collection of data stored in a computer system. Pretty simple. And how are databases used in the real world? They're used all over the place. Private, public institutions, they all keep their information in databases. And so your legislative bodies, your transportation centers, banks, schools, universities, they all access information within seconds from database systems. The world is full of data. We're constantly having data collected, whether we're using our cell phones, our computer. If you go to the store and you have a membership card, they're collecting information on what you buy so they can sell you more targeted items to your preferences. So when you access a website, that website collects your data, for example, where you are, what the date and time is, and it stores that in its database. Similarly, a commercial website takes your order in the database. Your bank stores your transactions in a database. Social media like Facebook, Instagram, Twitter, they use databases to store data like who the members are, their friends, member activities, messages, advertisements. And a database is typically controlled by a database management system. And you would hear that referred to as a DBMS. Data and the DBMS, along with the applications that are associated with them, are called a database system and are often shortened in the vernacular to just database. And there are many different database management systems. And on the market, you can see on the right, these are some common systems. And personally, I have used a couple in the images to the right, and then I've also used a couple that are lesser known in my professional career. Now, I have roughly 15 years working with SQL, some very basic work that I've done versus a very complicated work that I've done with SQL, such as data transformation and migration. And you may see some names up there that are commonly in the news. You see Oracle in the news a lot for their database system. You notice that Amazon has a database offering.
It is SAP, right? The Oracle database?
SAP is a different technology, but yes, it uses its database, its own database. Now, there are two types of databases. There is a relational database that is, it stores objects that are related to one another in kind of this logical relationship. We'll take a look at an image in a few slides that gives you some visual perspective of what relational databases, how they're designed. But there's also non-relational databases. And so the relational databases are, again, based on the relational model. And it's an intuitive, straightforward way of representing data in tables. The columns of the tables They hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish relationships among the different data points. And so in this particular course example, I will be using a relational database. And who do we have to thank for the database management system? Well, this gentleman in the picture on the right coined the term relational database. His name is Edgar Frank, or Ted Codd. He did his work at IBM in 1970. He introduced the term in a research paper entitled A Relational Model of Data for Large Shared Data Banks. And so thankfully they shortened all of that to relational database so that we don't have that type of title when we refer to them. So he explained in this paper what is meant by relational, and a well-known definition of what constitutes a relational database system is composed of Codd's 12 rules. However, no commercial implementations of the relational model conform to all of Codd's rules. So the term has gradually come to describe a broader class of database systems. So working with a database management system, and the topic of our course, SQL, which actually stands for Structured Query Language, and is accepted as a standard relational database management system language. So you saw all those different DBMSs on a previous slide. They're all working with SQL. So you have a lot of opportunity out there to run across some database that requires the use of what you're learning in the class today. So when we are referring to a relational database as SQL, non-relational databases are referred to as NoSQL. On the left, that is an example of a relational database, and we'll look at a much more complex image in a few slides. But you can see where in the color coding, they've shown that there is a relationship between one field in one table and a field in another table. And so there is an orange field or column. There is a green column. And then there's blue, yellow, red. And so your tables are related to each other based on the data that is stored in the like colored columns. In the lower left-hand corner of the slide, you can see an example of a SQL statement. We're going to get into that, but that is just a nice look at how statements are set up and how the result set of such a statement looks. Now on the right, you don't see the relational structure that you see on the left. And we're just take a look at that image. We're gonna let that be the last that we hear about NoSQL databases in our SQL class. For your work, we're going to be using Sqlite, and I'll be demonstrating Sqlite during this particular presentation. And Sqlite is a C language library, and it's pretty quick to install. It is the most used database engine in the world, and it's built into all mobile phones and most computers, and it comes bundled inside countless other applications that people use every day. So this is an excellent tool to become acquainted with as we move through this particular class. So Sqlite will actually serve as your playground as you move through the course. And you're going to install the DB browser for Sqlite to run the queries on your local machine. And Joshua, I don't know if you want to say anything further about that, where they can get assistance installing that if they have trouble between now and doing their homework.
Sorry, Kathleen, I couldn't.
Where can students go to get assistance if they have trouble installing Sqlite or the database associated with that they're using for?
They can ask their questions in Slack channels. Actually, during the live sessions, we use class chat, but today, for the first time, our friends, students all write in free courses channel. But if they use both channels, free courses or class chat, it doesn't matter. We can provide help for our students.
Okay, there you have it. All right, what is in a database? First, data in a database, it's grouped into tables. And a table in a database is called a database table. Tables are the basic unit of data storage in databases, and we use the term structured data when we refer to tables. You'll notice that the table looks like it is a combination of columns and rows. And you may think it looks similar if you've used Microsoft Excel or Google Spreadsheet. You may kind of see some similarities in there, but they are different, and we're going to talk about how. So a column is going to be a piece of data stored by the table. You're going to see where the row and the column intersect. That is called either a field or an attribute in many DBMS systems. The row is called a record, and that's a collection of related fields, attributes. Columns in a database, per table, they need to have unique names. It would be very confusing to the system if you had two first name columns, because when you execute the logical structured query language, it would know which column to select data from. So columns and rows together, they make up a table. What is in a database? So communicating with the database, you're going to be using the SQL language. And we're going to be modeling how you interact with a database. But this particular course, we're not going to design a database. And that's something that is very advanced. And before we get there, you're going to want to have that foundational knowledge of the basics, and that's what we're covering. Now, as you move along in the curriculum, you're going to be using different databases. And so that's nice to have that example where you're learning the foundation of the SQL language. Then you're going to see how it interacts with the various databases. All right, so what we've all come here to explore, and that is structured query language. Now, again, we've mentioned it. This is how we communicate with our database. This is a declarative language, not a procedural language. And so we are using simple declarations to hand to the database, and then the database executes that code behind the scenes. And a way we refer to this sort of declarative language, you can see the acronym there, CRUD or CRUD, create, read, update, and delete. And that's what it stands for. So some of the examples of what you can do with a SQL, you can retrieve data. Again, you ask the database to retrieve specific pieces of information, and it returns a result set. You can insert data. You can delete data. You can update data. And then you can also create a table and essentially create a database using SQL. Very powerful. let's get into the elements. And this is where we really start seeing examples of how SQL is used. This is a quote by Socrates. I like it a lot because it describes our time here today. And it just states the beginning of wisdom is the definition of terms. And we're going to be defining those terms in the next few slides. So SQL language elements, it's a cornucopia of color here. First, let's talk about the whole SQL select statement, the command that it's most common that we're executing this with the database to retrieve information. A lot of times for customers, they come to us, they ask for pieces of information, or if we're developing interfaces, first we have to tell the system what data we're going to be sending or what data we need to insert into tables as a part of that database. You can see here the simplest elements, and it is easy to read, is where we have here the word select, and you also notice the word from, and they're both in green. And down here, it actually explains what our components in green are. So we call them keywords, and they're special commands for SQL. Secondly, we have the yellow items. We have first name and we have employees. And these are identifiers. So select from, these are standard to let the system know what action we are taking and where. And then identifiers, these are where we further fine-tune what information, where the information is located that we want to work with. So this whole statement is known as SQL syntax. And I want to point out that this final pink element is a terminating semicolon. So that tells the SQL compiler, the database, that that is the end of our request. And as you work with SQL, I'm going to ask you to sear this pink semicolon into your brain, because it is the source of much frustration, so teeny tiny at the end of the statement. And it oftentimes can throw errors it always throws errors if it's left off. And I read a quote the other day that it was by a programmer, and they said, I lost 2 nights of sleep because of the semicolon, and that's true. So teeny tiny, but it will cause quite a stir if you leave that off. So this is a basic select statement. Select, we're going to work with many different types of elements over the course of our 3 sessions together. And you'll find that the select can be changed out for other commands. We talked about in a previous slide that we can retrieve data. That's what the select does. And then we also saw that you can insert data, and that's another keyword. So we'll look at examples of that as we go through. All right, let's begin working with our select statements. All right, so simply the select statement, you're retrieving rows from columns of in the table by using a select statement. Select, you'll notice our keyword here in blue, another keyword here in blue. They go together. You are selecting from a place. So what are you selecting and where is it located? Basic syntax. Let's take a deeper dive into the select syntax. So keywords, you'll see down here that we have a generic definition of what our identifiers are. So in this particular example, this is an actual field name that you would most likely see in a table of employees that you're working with, but this is simply the column name. And this is a table name. Now, you are going to, again, use keywords like select, insert, update, delete and all statements, I'll say it over and over, end with a semicolon. Luckily, for those of us that write SQL, it is case insensitive. There are areas of a SQL sentence or a SQL statement where it is case sensitive, and we're going to talk about that too. But your general syntax here, you can ask for column names in all lowercase. You can ask for table names with all lowercase, all uppercase. You can mix the case. These basic keywords and identifiers are not sensitive to case. Now, here's a common example of how SQL statements are written. And the most common method that you will see is uppercase. And if you're working with a database tool, a lot of times you'll see that it's defaulting to writing in uppercase. You'll notice that our SQL statement there is at the bottom 3 lines. So we've got our keyword select, and then we all the way down here have our keyword from. When your tool, like Sqlite, executes this statement, it ignores blank statements. So that's nice too, because this separation of keywords from identifiers, it really helps us in reading the statement instead of, especially when you get in long statements, instead of just having this single line. All right, let's go through and let's write a query based on the information in our database. I know this is kind of small, but this is an ERD diagram. You will possibly be working in the corporate world, the private world, and you are new to a position and you need to learn more about the database that you're working with. An entity relationship diagram, that's going to help acclimate you to the database. And so you can start off quicker working in that particular system. And without, it's a nice visual representation. So the ERD is a structural diagram for use in database design. It contains different symbols and connectors that visualize 2 important pieces of information. The major entities, in this case, our entities are tables, and the relationships within those, between those entities. And so an example in this particular image of relationships, you'll notice that the tracks table here, a listing of musical tracks and who wrote them, is actually related over here by this little line to genre. So what genre of music are we working with or listening to when we listen to a particular track? So that's what these little lines represent, is how this table or entity relates to another table or entity. So to begin with writing a SQL statement, we're going to use that tracks table, and we are going to request that our statement returns a track name from our track table. So I'm going to bring up my Sqlite that I am using. Let's just resize this. First thing I'm going to do, I'm going to open my database in Sqlite, just as an example. So when you do this on your own, you're going to install what we're working with is the Chinook database. You can see that already within my screen, this is an initial login of Sqlite. it's actually giving me a little hint there that I need to open a file, which is Chinook DB. All right, so working here. So that foundational structural language that we've been talking about in this particular section of the lesson, we're selecting basic information from our database. And so we want to start with the appropriate keyword that we're working with is, and that is going to be select. Now select, again, is we're selecting what, and what do we want to select? We want to select the track name from the track table. So come into tracks here, and we look for the name field, and that's what we're going to be selecting. So in my example here, I'm typing out name. That is the name of my field. So I'm selecting what? Selecting name. Then I add in my second keyword from, and this is where I tell it where the data is located. And the data is located in the tracks table. And then that's the end of my statement. But we've learned over the course of this presentation that we always end our statements with a semicolon. So to execute the statement, I'm just going to hit the enter key on my keyboard. And that's lovely. Stay tuned. Technical difficulties. Try to go back up to the beginning. All right. So back to our select statement up here. We've asked the database to return all the track names from our table. We hit enter, and then all of that information that you see is actually the data that we've requested. So you may you may or may not recognize these titles, but all the way from this particular line all the way down are tracks of data or tracks of
Are they fun or music?
What's that?
In the names of the list, there is
It
Just
is.
Friends,
It's
Mr. and
music.
this film and music mix, I think.
Yeah, it would make
So,
an amazing music.
nice list.
Saw one in there called Like a Shark. I don't know if that's a real song, but okay. Now, what I did there is I reviewed my what we call a record set of data or the output of the script. And then when I was finished reviewing all the data, I hit the enter key on my keyboard to actually bring up this item here. And we saw that at the beginning of our script, and I didn't point it out, but I want to point it out. By default, when you log in and you open your database, you're going to see a prompt first. And this is common regardless of the tool that you're using to query data out of a database. It's very common to see a prompt here, depending on how the database was set up. The prompt can be very small or the prompt can be very long. So commonly, you can see that this prompt is actually the name of the tool, but some examples of the prompt might be the server name that you're working on, so that you, when you're working with multiple windows and querying data out of multiple databases, when you look at your screen here, you know which database you're connected to. Practical application of that, in my experience, is you want to query information out of one database instance to compare to another database instance to see if they are the same, or to see if there are any differences between what's stored in each database. Okay, so this SQL statement, let me try to, let me highlight it here. There we go. very basic. So we selected data, specifically the name of a track from our tracks table. But if we go back to our example here, what if these tracks are nice, makes a good playlist, but what's a nicer way to list out tracks so that I can actually build that playlist, say in my my Apple Music or Shazam. It would be nice to know another element to the data. So who is the artist? What is the or composer, artist composer? How large is the data file? Things like that. So let's take a look at how we do that. Here's a generic example of the structure of a SQL statement that is requesting multiple column data to be returned. You can see, so our simple statement here, and then the output of what we're looking for. So here's our example table, and we are looking at 3 columns in our sample table, and it has 3 records. And so for our example, I actually want to return back from this table the values in column 1 and the values in column 2, but I don't need the values in column 3. So what we do to identify the fields that we want to bring back. So I'm selecting what? I'm selecting column 1 and column 2, is we separate those field names with a comma. And another tip as you go through writing your SQL statements is your from keyword has a space between our field names and our keyword. Similar to missing a semicolon, if you have a comma here before from, it's going to error on you because from is always expecting a space between a field name and keyword. Once we execute this simple select statement, it returns back the 2 columns that I've requested. You can see down here in output, we only have the 2 columns. Then it's listing out those values that we see. So select 2 columns, and it's bringing back column 1, value 1, 1, value 2, 1, value 3. Then in the column 2 data, value 1, 2, 3. You can see that. All right, so let's see an example of requesting multiple columns with our database that we have come to know and love.
Sorry, Kathleen. We come to the break time.
Okay.
But we can make a break for 10 minutes. And
all right.
Just start for the next in the exact time.
All right. So you want to come back at 12 exactly Eastern time?
Yes.
Okay.
But let me remind for today, the last lesson will be 1 hour to reach the points, right?
Mm-hmm.
Okay.
So we'll be ending at 1 p.m. Eastern time.
Okay.
So I'll see you guys back here at noon, and then we'll get into an example of selecting multiple columns. So I'm going to leave this up so you can take a look, sort it, and then I will see you back in 10 minutes.
Thank you.
Great. Just before we get back into the lesson, I did want to add or provide some answers to some questions that are coming in to our chats. Where can we find the tools that I'm using? So Sqlite, and then also the Chinook database. In the LMS, you are going to see the My Courses action, and then there will be the Mini-Bootcamp course. And so over here on the lower right-hand corner, you can see a button called Welcome Kit. When you go into the Welcome Kit, that is going to have the downloads for you to use. And like we talked about at the very beginning, the Sqlite installation is very easy. I installed it at the root of my C drive. You can see. I just put it there. And then I unzipped the database in the same folder that I set up Sqlite in. So just to give you an example. Sorry, I'm trying to get back to sharing my screen there. Okay. Must have shut off. Okay, here we are, selecting multiple columns. So we learned that to request from the database multiple columns, or separating those column names by a comma. In our example, we're going to be switching to another table that we're pulling information out of, and that's going to be the albums table. We were taking a look at that relational database that we were working with. We were using the tracks table. Now we're over here in albums, and I've already typed out the select statement for what we are requested to request from the database. And so what we're doing is we are requesting a information from that albums table, and we want to see all three of these fields return in our record set. So go ahead and put that particular request in there. And all right. So what we requested is album ID. You can see numbers here on the left-hand side. Title, there is our title. And then the artist ID. So that is all the information from the albums table. And there was a lot of typing. So you can see I typed out 3 fields. Spare, 3 fields, not so bad. What about tables? It's not uncommon to have 150 fields. If you want to speed up the process of writing out your select statement, you can actually use a shortcut. So selecting all columns, shortcut. Instead of typing out all of those fields, we have, luckily, a little special character, the asterisk. So if I type out that statement, instead of listing out all of the different fields, I'm trying to get down to my prompt. I can see that I have retrieved the same record set. So all of our albums. And that is just using the select star instead of all of those field names separated by columns. So that's a real nice feature, very helpful. So a little test, if we were to select all of the fields from our tracks table, how would we write that? select star from tracks semicolon. When you write SQL statements, especially complex SQL statements, it is not uncommon to get duplicate records. And so where we have a need to simplify and only bring back unique records, so we don't see all those duplicates, we have another keyword that we can use. And this one is referred to a clause. You can see there that we use this distinct clause in combination with select. So our request to retrieve always start with select, and then what we see is it is immediately followed by the word distinct, and then your column names and from which table. So let's take a look at that. So on the left-hand side, you can see that this is the student table. This is all the information stored in the table. And if we look at our first example of the student column, you can see that if we do the select distinct student from the student table, we have 7 records in our table. And if we come over here, we have 7 records returned. So obviously, using select distinct, we do not have duplicates. So if you use distinct with select and you don't have duplicates, it essentially just brings back all unique values. But if you do have duplicate values, you can see now we're using the lesson column. You see mathematics repeated in that column. You can see physics repeated in that column. So where we have a select distinct from the lesson, in the table we have 7 records. In our result set, we only have 4. So if I only want to bring back unique names of composers from our tracks table, what you're going to see you write out this example. Each composer in our table listed only once. Now, if, and it's not uncommon, if your field does not have a value, then your record set is also going to have a record for null. All right, so an example to show you that, I have another distinct statement. So you can see here, we have 2 different fields coming back. When we use distinct with multiple fields, then it is a combination of the values that it brings back as distinct. So it has to be a unique record. So to select distinct star, you're going to get unique records for every field in the table. What we've been looking at so far, it's been a lot of records. You can see in this example, we've got hundreds. So what if I need to bring back a more refined record set? That is where we bring in the where and limit clauses. So how we write that out, our syntax, is we're just adding to what we know so far. So select from another keyword where. This is going to be a specific search condition that we want to see returned back. Now, where clause operators, you can see that we have equal to, greater than, less than, greater than, equal to, etc., etc. And then later on, we'll talk about between, like, and in. For now, we're going to start with the most common, and we want to see record sets come back for that match a specific filter value. So in our example on the left, our student table, we have queried this before, and we saw that we had 7 distinct student records, we had 4 distinct lesson records, and now we want to see in our record set only records where a student has scored over 70, a grade of over 70. And so this particular statement here evaluates all of the values here and only returns the entire record where this part of the statement is true. So if I want to bring back records where the student lesson was mathematics, in this particular example, in my where clause, I'm going to put the field name, lesson, equals mathematics. And so you take the value here. This particular value is case sensitive in our example. So I've put here that value specifically in quotes. And that lets the system know that this is a string value, and I want to see that exact value. End it with a semicolon. It returns my records and shows me only records where the lesson was mathematics, and I have 3. Switching that up a little bit, who got a grade of less than 70? Change my filter, grade less than the value 70. You'll notice there's no quotes. That means that this is a number value. It returns back 2 records. So unfortunately, 2 folks at a lower score. So for our example, what I want to do next is I want to filter out all of the tracks where the composer is Jimi Hendrix. So I write out my select statement. I want to see the name of the track from our tracks table where the value in the composer field is Jimi Hendrix. And in this particular example, we can see that it's offset by these apostrophes. Apostrophes are specific to the tool that you happen to be using. So you may see the quotes in our example, or you may have to use apostrophes. So don't be thrown by that if you see that in another compiler. End it with a semicolon, and here we go. All of the tracks, much shorter list than we saw earlier, that have Jimi Hendrix as the composer. Okay, another example. What about a table we haven't worked with? Over here, the invoices table. I want to see every record from the invoices table where the total number value of that invoice total is greater than 10. You can see it brings back a multitude of records, a multitude of fields. Because I used 2 of the concepts that we've talked about combined. So I used our asterisk, which says bring back every field in the table. And then I've said, but only bring back records where the total field is greater than 10. Limit. Again, another way to filter out our record set so that we get more specific information than just querying everything out of the table. We use the limit clause. So similar to where, let's go ahead and down to the prompt. The limit clause constrains the number of rows that are returned by the query. So you can see where we were using in the last example, the keyword where. Now, after our table, we are now using limit. And the value that we combine with limit is going to be a number of rows that we want to see come back. So in our example on the left, again, our student table, I only want to retrieve 3 records from the table. So I want to select all fields from this particular table, but the first 3 records. So when I execute that request, I come here, 1, 2, 3, I should see the same 1, 2, 3 records below. So let's change that a little bit. Let's add to that. Select star from student table. Now we have both where and limit. You see after the from section here, from keyword, I'm going to say bring back all fields from that student table, but I only want records where the grade is above 70. And out of that record set, I only want the first 2 records. So our first 2 records in the table, the grade, 95, 65, you can see that if I were to just have that where clause, I would get the first record, and then my second record would come down here to 85. I have the limit clause, and I've said 2. Because these 2 are used in conjunction, instead of getting the first 2 records out of the table, it evaluates where, and I'm going to see I have a possibility of bringing back student 1, 4, 6, and 7. It's going to limit those 4 records to the top 2. So it's only going to bring back 1 and 4. And you can see that in our record set below here. So another example, I'm going to use a combination. We're going to be pulling again from that invoices table. So invoices table. I want to bring back all fields from the table where the total is greater than 10. So what we saw, lots and lots of records, but I only want the first 4 records out of what we previously queried. So that results in a much more manageable view of how the data is stored, what sort of information is in there, and then, of course, if we want to build on that and bring back even more, we can. But limiting your record set is a nice way to further filter out data. All right. Often, the data comes out in the order it was entered into the table. That's a database default. It does get more complex than that, but just like you see in reports, sometimes you want to order your data so that you see more relevant information at the top, like you want to see things in alphabetical order, or you want to see numerical values in a specific order. What you see in your syntax is you add another keyword, so select from, and then order by follows from. Order by, it can be used with the keywords ASC or DESC, and those stand for ascending or descending order. So let's look at an example of that. So in our example here, this is our employees table. Again, bring back every field from the employees table, but order everything by this first name field. You can see we've got ERB. So obviously, by default, we're not seeing an order by first name. When I run this particular request or statement, I've said first name in ascending order. So that's A through Z. And you can see how it comes out in the data set. B, D, E, we have our alphabetic order. Now, the order by is actually dependent upon the data type. And so first name, obviously, that's a string or letters, and it's going to use alphabetical order. But we talked about it, you can also use numbers. If that field stores numbers, then something like salary, you're going to see an order by number. So it knows, based on how we've set up that table, how to sort, what sort method to use. Similarly, if we want to see everything in a descending order, you can see this is our statement, just we've changed this keyword from ascending to descending. And now we're starting from Z to A, R, L, and Billy and David, they're way down at the bottom. All right. So we've sorted our text. Let's talk about or see an example of sorting by number. So we're writing a report for somebody and they want to see who are our high earners down to our lowest earners. So we have our from, order by, salary, descending. Again, the database knows that we have numbers stored in the salary field, and we want to see the largest first, so we use descending, and this is our record set, 110,000 down to 55,000. You'll note here over to the left, we've been using that asterisk keyword a lot, or identifier. In this particular record set, we actually went back to, we don't need all of these fields. We went back to listing out specific fields. So that's why in our previous example, we had all of these columns come back. In this example, we only see 3. Now, it is common in a data set that you want to sort by multiple columns. So first sort by column last name, then sort by column first name. And how we do that, similar to how we were separating out column field names, we are also going to separate out those field names with commas. So an example of that, and this one's a nice example because it starts building on what we've already seen. So we've got an order by gender. You see in our record set, male, 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 female, female. It actually assigned or told the database to bring back the value gender in descending order. And then sort by first name. So what this actually does is it takes a look at the values in gender and says, okay, well, I have male and female, so bring back all the males first. But within that male record set, then I want you to order the values by first name. So we have descending order gender, ascending order first name. What happens if we need to combine a filter and a sort order? In that instance, we actually put order by after the where clause. Again, we go back to that point I made earlier where we have the SQL statement separated out by lines. Once your SQL statement starts to get more complex where you're using these multiple keywords, it actually is much easier to read that statement if you start separating out the statement keywords by line. So you can see here we have the same statement as above, beautifying. But we start our select from where and order by clauses on separate lines. So now we'll start writing our statements in the separated lines format. So this one, in our table, we're filtering out only records where salary is greater than 80,000. We haven't specifically talked about all those different operators, but this particular operator, same as with your basic math, it's not going to include the value 80,000, sorry, only higher. So that particular operator, if you wanted to include 80,000, that would be greater than equal to. In our example, I'm filtering all these records out by who makes greater than 80,000. And then out of that, I want to order the values by first name in descending order. And you can see this is our record set. Again, we're going back to that asterisk or all fields. We'll go back to the invoices table. I want to show an example of how that is written. All right, so in this particular format, we've got our keywords separated by line. Let's do this. Actually used from on the same line as select. This is valid. Again, we're ignoring those blank statements. So if you wanted to combine select and from on one line and where and order by on one line, you're not going to cause any problems. So we're selecting all records from invoices where the total amount of the invoice is greater than 10. And then I want to see that total in descending order, that total column in descending order. So as we go back through our record set, all the way here at the end, it shows me my largest value or my largest invoice at the top. And if I come all the way down to the bottom, I'm going to see the invoice for the smallest amount, 1091. And or and not operators. So and or not. We talked about filtering out data, and so far it's been pretty simple. We've said, I want to see a specific field that values that the value is X or is greater than X. What do we do if we want to see data with multiple filters applied? So let's take a look. So and or not, these are keywords and they are called operators. And their purpose is filtering out our data based on conditions. And they are used in conjunction with the where clause. And so this is just our where clause. Recall that we first have to say select from, and then where we have our condition. So where one condition and left condition and right condition are true. And that's how this statement is evaluated. So I want you to bring back records where something is true and something else isn't true. Again, we're further limiting our data set. So from our employees table, this is how we write that out. Again, we're using text values and specifically from employees, all fields, but I only want to bring back an employee that has, or all employees that have the job title data scientist, and those employees must be male. And so what we see is we can go through and we can search data scientist, and we have Linda, and she's female, and we have David, and he's male. So if I say bring back everybody with data scientist as their job title, it would bring back 2 records. But I further defined or filtered that data by gender, and I can see that only 1 record qualifies as true. And so I get 1 record back. or. Similar to and, we have or. And so the and, both conditions have to qualify as true. Or is a little different, where it says, bring back records where the first condition is true or the second condition is true. So we're evaluating either condition. So again, same statement, bring back all the records of the table where the job title is data scientist. We saw that we had 2 records, but also bring back records if the value is male. And so you can see we've got numerous male records in here, and that's where you see a much larger data set because it's evaluating 2 different things and bringing back a record set where either is true. Not. And not is an operator used in combination with where. You can use it also with the 2 that we've just talked about, and or operators, but it actually says evaluate where something, a condition, is not true. So let's take a look. So we were looking at records that the condition was male. This is saying bring back all the records where gender is not female. And how that evaluates to true, we only have 2 values in this table. So that says any record that is not female, 1, 2, 3, 4, 5, 6. So what comes back are the 6 records that evaluate as true, where the records, the gender in the field gender does not equal female. All right, let's take a look. Let's take a look at an example. All right, back to our invoices table. We love visiting it during our examples, and we have select all fields from our invoices table where not billing country equals USA. So only bring back invoices that are not billing the country USA. And then we add to that where we see order by. So talking about multiple keywords that we're using together. So always select from where, and then within where we can use and, or not. And then we saw earlier where is followed by order by. You can see if I run this, I am only getting records back where the country is not USA. Between is another nice filter that we can use to bring back specific records. And that is known as a comparison operator, where we can see if a value is within a range. And so if we declare that we want to see all records where test expression is, well, I'm not saying that well, but in this particular syntax, we're actually saying I've got my test expression, so where invoice billing value is between, say, 10 and 20, that's going to bring back a much smaller record set than what we've been using, where our invoice value has been greater than 10 or less than 20. In this particular expression, we just combine 2 conditions and it actually evaluates and brings back that limited record set. Another way to write this out with what we just learned is we could use that and then we would have to have 2 comparisons and we'd be repeating ourselves. So using between is just a shorter way of writing out 2 conditional evaluations. So again, test expression, we put that once, twice, Then we say I want test expression to be greater than or equal to a low value, or what we're testing or evaluating for to be less than a high value. This is the long way of writing that out. Our example is I want you to bring back all records from the employees table where the salary is between 80,000 and 90,000, where we were bringing back records before where we wanted to see everyone that maybe made more than 80,000 or less than 80,000. Here we're actually limiting it even further, and I only want to see people making within this range. We evaluate our table for salary. You can see that we only have 3 people making between that 80 and 90,000 range. And there's our record set. We can also use not between. And so we had in the previous example, we had an expression that was bringing back data within a range. This is the opposite, where we want to exclude a range. So again, where that test expression is not between something low and something high. So let's take a look at that. You can use the between operator with dates. So we've seen that we've been using that salary value. We can also evaluate for dates. And so we see in our hire date column here, we only want to see people that were not hired within a certain date range. And so I come here, I want to see from my, oh, sorry, this is not, this is just with dates. We want to see here in our record set values that come back for a date range between. So you can see hire date, we want to see anybody hired from the 1st of June in 2018 through March 31st, 2019. We do also want to order it by hire date. So when it goes through and evaluates that hire date field, we only see 5 records returned. So everybody else was either hired earlier than June 1st, 2018, or later than March 31st, 2019. All right, let's look at another example. So in our example here, I only want to see from our invoices table, invoice dates. And specifically, I only want to see invoices or records that have an invoice date between Jan 1, 2009 and Jan 1, 2012. I'll add that if you switch your date so that the highest value is before the lowest value, you will get an error. And using dates is a little tricky as well, because when you store dates, oftentimes you're storing the timestamp along with that date. And so when you use between, it's going to be inclusive of a date time combination where the time is set at 0 hours, 0 minutes, and 0 seconds, or midnight for that date. And so this particular record set is going to be inclusive of endpoints. So 2009 Jan 1, we're going to bring back values that include, say this is Jan 1, 0 hours, 0 minutes, 0 seconds. It is going to also bring back the value between Jan 1, 2012, 0 hours, 0 minutes, 0 seconds. So when we go through and we bring our records or our invoice dates back, let's go ahead and hit enter. You can see that it's bringing back our date and time of 0 hours, 0 minutes, 0 seconds. When you run these queries and you just put the date, it does get tricky because it can bring back or exclude values that you're not intending. So always beware of that hour, time, minute component to a date time field when you're writing your queries. So let's go to in. What is the in operator? The in operator is used to determine if a value matches values in a list. And so that is going to be, that can be text, it can be numbers. And how that is written out is it's in the where clause, and we have a keyword in, and we say that we want to see any value where the column name, within this list of values, the column name matches that value. So here, let's go back to our employees table. In this particular example, prior to this, we wanted to see employees that only have the job title data scientist. Well, now we're interested in seeing any employee that has a job title that matches data scientist, that matches business analyst. And so what we do with those, this is specifically a text value. So we do denote it with these apostrophes. Bring back any record where the job title equals data scientist, or the job title it matches business analyst. When we come here to the job title field, we see that we have, again, 2 records for data scientist, and then we have 1 record where the job title is business analyst. So bring back all fields from that table where either one of these values is true, and we get 3 records. So this is a quick way of how we were writing out before that or. This is another way to pick and choose which values you want to see back. Okay, so this is a longer version of what we just saw. And so this one, we want to bring back data scientist, business analyst, as well as project manager and web developer. So from the previous table where we had our 3 records come back, we add those 2 additional values, and now we have 6 records come back. So as you build your match conditions here, it's going to add matches to your record set. If it does not find a match, it just won't bring a record back. You won't get an error, nothing like that. So what we talked about where we were writing out our or statements, the in operator, that's going to be a little quicker method to write out where you want to see those conditions match or match or match. All right, so not in. We've seen are not operators. This is another example where we're using not. So I want to exclude records coming back that do not equal operations director or HR manager or sales manager. Again, we're just expediting writing out that query using the in and now in combination with not. So where do the job titles not match these 3 values? You can see here's our record set. And in this record set, we have 7 results. So let's use this in another way from our actual database. And here I have I'm selecting only 2 fields from our customers table over here on the right, where the country is in one of 4 locations. So only bring back, for my example here, countries where the customer is located in Belgium, Norway, Canada, or USA. So if I run this, you can see that oh, what did I forget? Got a little error there, which is going to take a while to process. So back to this, where I have this statement. You can see in this particular example, I'm missing a character. I have to put my semicolon. So once I put my semicolon, it tells this database tool to retrieve the statement. And here we come back, and I've asked for only the first name and the last name of customers that live in one of our 4 countries. If I were to say not in, it would bring back the records where the customers were not in Belgium or Norway or Canada or USA. All right. Like. Moving into our last operator that we're going to talk about today, our like operator. So we have talked about very specific values that we want to see a match for. So I want to see records come back for exactly, that equal exactly operations director, exactly HR manager, exactly sales manager. When we use the like operator, we can say, well, I want to see records come back that match a specific pattern. So where we or how we actually write this out is we ask the system to use a wildcard. And the wildcard that SQL uses is the percentage character. And then we have a note here that the underscore character matches any single character. So let's take a look at how that works. So from our student info table, it's very, very small. I apologize about that, but we want to see at all fields from our table, from student info, where the county is like the value that starts with capital W, lowercase 0, and then it can be any combination of characters after that. So if I go through my county and I look at all the values, I've got a T, a W, a K, it's not going to bring those values back because they don't start with a capital W, lowercase 0. It does find one match. It finds county would, and it brings back that value. Similarly, we can use that percentage at the beginning, and we say, okay, we'll bring back the field, the student info field column, where it starts with any character, but it must end with capital D, lowercase e, v, e, l, o, p, r. So you can see over here in the field column, it finds out of all these. I've got DevOps, I've got data analysis, and it goes through our record set and it brings back, hey, well, I've got a back-end developer, a front-end developer, and so on and so forth. Underscore character. So the underscore character, we can put the underscore in the middle of a value of characters, and it brings back, it starts exactly with E, capital E, lowercase l, and it ends with exactly lowercase I, lowercase s. And it goes through and we're evaluating for first name and looking through all these values. It only finds one record that actually matches that. And you can see that it saw that there was a V in there. This is actually saying any combination of characters. So it could be Elvis, it could be Elvis, making up names here. So that's how the underscore works. So let's look at a practical example again out of our tracks table. Go ahead and put this in there. From our tracks table, bring back a composer and the name of the track from the table where the composer name is like. I'm not exactly sure what the beginning value in the field is, but I know that I want the value that ends with capital B, lowercase ach, to return. So when I do that, you can see that my composer name, Johann Sebastian Bach. This is useful in case somebody had entered into this field J.S. Bach or Johann Bach. This record set would bring back all of those matches. And so it is a good way, if you're not exactly sure how data's been entered into a field and it's been verified, say it's a free-form text field, this is a good way to locate those different variations. So we come to an end of our lesson.